The first set of problems all have to do with this drawing. And what you need to notice about this drawing, a couple of things. First of all, these two lines here are parallel. Okay? Now notice that this is not part of this line here. It's these two lines that are parallel. Okay? And little by little, you're asked down here to fill in the angle measurements of some of the other angles and explain how you knew. Here's angle ABC, and you're asked for the measure of angle CBF, and these two angles you should recognize immediately are a linear pair. CBF is related to angle ABC, and as a result they have to add up to 180 degrees. They need to be supplementary, so that's 50 degrees. So we now know that's 50 degrees. BCF. These two angles are same side interior angles, but they are not going to be supplementary because these two lines are not parallel. If these two angles added up to 180 degrees, then this would have to be 0, but it's not. This is 50, this is 110. Triangle angle sum theorem says that the sum of all the angles in this triangle has to be 180. That means this has to be 20 degrees. So angle BCF has a measure of 20 degrees. The related angles here are angles CBF and CFB. By the way, you notice that you can't call any of these angle F or angle C, because if there's more than one angle at the vertex, it gets confusing. You got to use 3 letters in order to identify it. Yeah.
So that was the one bit I didn't understand. Like, why are they related angles?
Why are these related? Because they're part of a triangle.
Oh,
Okay? Their relationship is just that they are a triangle. HFG, that's this angle right here. And that one is congruent to this one because they are vertical angles. So HFG is 110 degrees. Okay? The related angle is BFC, and they are vertical angles. Okay? The next one is HCD, this one right here. Okay. Well, we are now working with 2 parallel lines. And this angle and this angle are corresponding angles. These 2 angles are alternate interior angles. And depending on which way you want it to go, you can mention either one of them as long as you explain what it is you know. Angle HCD is 110 degrees. I'm going to say that the related angle is HFG. And here's what you have to say, and this is critical. They are corresponding angles, but if that's all you put, I'm going to write always. Corresponding angles are congruent, but only when the lines crossed by the transversal are parallel. And you have to say all of that, because otherwise I don't know whether you know that corresponding angles are only congruent when the lines are parallel. CHD, all right, well, that's part of a triangle too. CHD, and then back over to C. And if this is 110 and this is 40, that's 150. That means this has to equal 30 in order for the triangle angle sum theorem to hold. So what we wind up saying is that this angle is 30 degrees. The related angles are HCD and HDC, and the relationship is a triangle. If you say triangle angle sum theorem, I'll know that you knew that it was a triangle. Yeah.
Say you only wrote one of the angles for the two, would you still have full clarity?
If you only put one angle here and you tell me that you figured this out because of the triangle angle sum theorem, I'm going to wonder, where's the other angle? Do you really know what this means? This is the thing that messes people up more than anything else, and it's the parallel line theorem. First of all, you have to read really carefully. Determine the value of x for which line A is parallel to line B. Does that say that line A is parallel to line B? No, it doesn't. In fact, it specifically implies that at the moment, they're not parallel. In order to make them parallel, we have to find the appropriate x. So what are we doing? In order to find parallel lines, we need to make the alternate interior angles congruent, because if the alternate interior angles are congruent, then the lines are parallel. That is what you need to say. In order to make them congruent angles, we need to make their measures equal. If I add 2 to both sides here, this is 13x plus 4 equals 15x. If I subtract 13x from both sides, I get 2x over here. And then if I divide by 2, I get x is equal to 2. And that's the answer. X is equal to 2. And why does x have to be equal to 2? Because it will make these two angles congruent. And if the alternate interior angles are congruent, then the lines are parallel. This is what you need to say. And what you have to do is tell me that you know why making them congruent makes the lines parallel. If you just did this, even if you then went back and said, now I know the angles are congruent, what is it about those angles that makes them related at all to the lines being parallel? It's specifically, these angles are alternate interior angles, and if alternate interior angles are congruent, then the lines are parallel. That's what we're looking for. And just to make sure that everybody is clear on what it is, we have already said and shown that all three of these things are the same. The alternate interior angles are congruent, or the corresponding angles are congruent, or the same side interior angles are supplementary. You can't have one of these without having the other two also be true. So if you recognize any one of these, then you have identified a situation. And if this, then the lines are parallel. And that's the situation where you know, or you figure out the measure of the angles and you are trying to prove that the lines are parallel. When that happens, this is what you need to say. Because this is what says it. This is how I know the lines are parallel. If this is true, then the lines are parallel, and I just showed you that this is true, so the lines are parallel. The other way you can use these is to say, if two lines are parallel, then these three things have to be true. But that's the situation where you already know that the lines are parallel. And if you already know that the lines are parallel, then you can start to talk about the measurements of the angles that are created by the transversal that crosses them.